Hi, today I'll show you how to use the 4017 counter chip along with the button to cycle through multiple LEDs. You will need one 4017 counter chip, 2 to 8 LEDs, one button, 2 resistors, which I'll get into later, and jumper wires, preferably flat breadboard wires. You can easily find these components on Amazon for a relatively cheap price. If you want to understand how the components in this circuit work, you will need a basic understanding of breadboards. Without any further ado, let's get started. Before we begin, there is one part you need to change depending on how many LEDs you want. If you don't want to watch the whole tutorial, you can skip to the timestamp in the description or the pinned comment for the information. So to start us off, I have an example circuit on the left side of my breadboard. This can be a helpful tool in case you can't follow along with what I'm saying. The first step is to connect the 2 power rails on either side of the breadboard, as you can see in my example. I've already connected the 2 rails together, so I won't have to connect them again. This is a crucial step, otherwise half of the breadboard won't receive any electricity. Next, you want to place the chip in the middle of the breadboard like so that the legs are on either side of the middle notch. Make sure that the semicircle you see here is pointed left. Now, you want to place your LEDs near the chip, with one leg on top and one leg on the bottom of the notch. When doing this, make sure that the long leg is on the bottom side of your breadboard notch. The long leg of an LED is called the anode, and the short leg is called the cathode. The anode receives the positive electricity, and the cathode is the discharger. Now just place the button like so across the notch. Make sure that the 2 pairs of legs that are close to each other are on the same side of the breadboard. Now we can start placing wires. I have the data sheet here with me so you can see which leg does what. We're going to start with leg 16 here, which is this leg on the chip. This is the power leg, so we will put a wire from positive to that leg. We'll skip over these next 2 pins for now and go straight to the enable leg, which is leg 13. This leg allows the clock to cycle through the different outputs. I like to call this leg the inhibit leg. Enable makes you think that you need to give it positive, but you actually need to connect it to ground. We'll next go back here to leg 14, the clock leg. The clock leg is what makes the chip cycle between different outputs. To change outputs, the clock leg has to go from being connected to negative, to positive, and back to negative. We can do this by constantly connecting it to ground, and then when you press the button, the clock leg receives positive. You want to put a wire from here to the top left leg of the button. You just need any high resistor. Right here I have a 10 kilo ohm resistor. I recommend anything 10k and above. You connect the resistor from here to the negative rail. Continuing on with the button, we'll connect the bottom right leg to the positive rail. Now we'll start connecting the LEDs. This is the part where it depends on how many LEDs you want and even the color of the LEDs. You'll need to connect the positive leg of the LED to 1 to output 0, LED 2 to output 1, etc. In this case, I have 4 LEDs, so I need outputs 0 to 3. You need to make sure that you connect them in the correct order, otherwise the cycle of LEDs will get messed up. I'll quickly connect my 4 LEDs now. Again, remember to look at the schematic to see the legs that you need. Now we just have 2 legs left, ground and reset. The ground pin just needs to be connected to the negative rail. The reset pin is what makes the chip cycle between the exact number of LEDs you have. Without anything connecting to this leg, the chip automatically cycles through 9 pins. Since we only have 4 LEDs, we need to stop this cycle early. The last output we used was output 3. The reset pin should connect to the output pin after the last one used. In this case, we need to connect the reset pin to output 4. If you skip to this part from the beginning, you can stop now. We're almost done. Now we just need to connect the LEDs to ground. Most LEDs need a resistor, but my green LEDs don't. This is again a part where your circuit will most likely differ from mine. You need a 220 ohm resistor to stop the LEDs from burning. Place the resistor on the same row as any LED that needs that resistor. In this case, I'm putting it with the blue LED. The other leg of the resistor should go into the negative rail. Now, you want to connect the negative legs of any LEDs that still need resistors to the same row as the resistor that you placed in before. We now have 3 out of the 4 LEDs properly connected. Because the green LED doesn't need a resistor, you can connect it directly to ground. The circuit is fully complete, but there's no electricity yet. At the bottom of the breadboard, you can connect your power source to the 2 rails. I'm using a DC power supply with alligator clips connected to the breadboard. The circuit takes 5 volts. I highly recommend using a DC power supply, but you can also use a battery pack if you have one. If you have any questions, feel free to comment them and I will respond if I have the answer. Take care.